Well, in this video, we're going to talk about blood typing. Now, blood typing, this is going to really cross over from a lot of the stuff that you've seen in lab. Probably is a good thing to go over it again anyway. You've got the video to watch from lab, but this is going to be the last of chapter 14, slides 50 through 59. So, first of all, talking about blood typing, one of the things you have to understand is the players of this dance. And so there's some things that go on, and we need to know that when we look at a cell, there are structures on the cell surface, and one of the structures is or a couple of structures that are going to be used to identify the cell. And generally, it's identifying the cell as self, so our body will know if we need to attack it or not. So things that come in to our body will have these proteins on them that are different than ours. Now, these things are called antigens. And so we use the term antigen in blood typing, and it's easy to think that that's what's on our cell because it is. But the name truly means an invader. And so what it would be is, like, let's say I have antigen A on my cell, and since there's only two antigens in the ABO system here that we'll talk about in a second, the B antigen is an invader. And so that's where we get the name. So this is what we're going to look at right now, the ABO system, and it is simply about the antigens A and B. We have another type of antigen we're going to look at. It's an RH factor. That's where we get either our positive or negative part of our blood type. But we're going to look at that kind of separate. So they learned really quickly that blood can't be really mixed. There's certain blood types that will attack each other basically. And so they started looking into it and they realized that it's these proteins that are on the cell surface. Now, the way that it works is we have something called an antigen that is on our cell surface, and inside our plasma, we have something called antibodies, which go around and look for harmful antigens. And so these are the two parts, the two main players of this play. Antibodies, which are flowing through our plasma, and antigens, which are going to be found on the cell. Now, we looked earlier in this chapter that antibodies are these special little things that are called gamma globulins. They are part of the group of things called plasma proteins. Remember that. So let's look and see what we've got here. So this gives us some basic definitions. The term antigen, the definition is actually any molecule that invokes an immune response. In this instance, what I want you to know is antigens are on the cell. All right, and that's going to differentiate it from these other guys called antibodies. So it says up here, going back, if the immune system finds a foreign antigen in the body, it produces antibodies against that antigen. That's why we call it an antigen-antibody complex. So antibodies, again, are proteins that react against the specific antigen. If an incompatible blood transfusion happens, the donor of red blood cells evokes an immune response to the recipient. And the antibodies in the recipient's plasma will do something called agglutinate to the donor red blood cells. Agglutination is simply a fancy way of saying blood clotting. An abnormal blood clot. So it's the clumping of the red blood cells, and it's going to be because the antibody, when it encounters the antigen, it will connect with it and cause that cell to produce a sticky substance on the surface, and it starts sticking to everything around it, and the blood cells will clump up. Now, this goes through, I don't care that you know that there's 33 known antigens on the red blood cell membranes. I'm not worried about you knowing that, but I want you to know that it's far more complicated than just this, but this is the basics of it. Only the antigens of the ABO and the RH groups invoke serious transfusion reactions. So of these two systems, the ABO system and the RH system, there are only three antigens, A, B, and RH. And that is it. That is it. That's all there is. We want to add things, but it's as simple as that. Now we're going to keep moving. So when we look at the ABO group systems, this is what it says, and kind of it says that there's basically only two major antigens, antigen A and antigen B. I don't care that you know that these are carbohydrates, but you know that might come in handy down the line, but I'm not going to ask you about it. So what we're going to look at is if I have antigen A, I will be referred to as A blood type. Now, when I am developing as a fetus in my mother's womb, there's an early point in time where my body will start creating red blood cells. And at that point, the red blood cell, and I'll draw it over here, is going to have an antigen form on its surface. And let's say this is A. Whatever antigen I do not have, I will make an antibody for it. That means that that antigen is my foreign invader, my enemy. So if I am type A, that means I do have A antigens on my cell. That means I do not have B antigens. Therefore, B antigens are my enemy. So my body makes anti-B antibodies. So when I am born, I've got cells with A antigens on them, and I will be forming anti-B antibodies to protect my body against B-type cells, blood cells. And so remember, I can't recommend strongly enough to remember, obviously because it's correct, but the other thing is it just helps you understand what's going on. Remember, antibodies are called anti-whatever. I have students that just continually want to forget putting anti in front of the antibody. Anti. If I know that something is anti something, I know what it does not like. For instance, if I am anti-gun, I know that I don't like guns. If I am anti-whatever, I don't like whatever's after it. If I'm a football fan and I am anti-Clemson, that means I don't like Clemson. If I am anti-Gamecocks, that means I don't like Gamecocks. Make sure you put anti in front of it. Not only is it correct, but it tells you all you need to know. If I ask you, what does anti-B antibodies dislike? What do anti-B antibodies attack? You should tell me pretty straightforward that they attack B. If I went to a kindergarten, well, maybe not a kindergarten, but if I went to a grade school and I said, all right, I've got something I'm going to call anti-B. What does it not like? They should be able to tell me it doesn't like B. All right. So when my cells are forming, whatever antigen I do not have, my body creates an antibody to fight it off. So we move to the next one. If I am type B, that means I have B antigens on my cell surface. That means I do not have A, which makes it my enemy. So I will produce anti-A antibodies, and they will attack A antigens. Now, here's where the kind of tricky part comes. If I have both, that means I'm type A and B. That means I have type A antigens and type B antigens on my cell. Since there are neither of the two antigens that I do not have, that means I don't make any antibodies. That means I have neither anti-A or anti-B antibodies. Right? Since I have both of them, if I was to create one of the other, it would attack my cells. And then finally, the only other combination that could happen would be what we call type O. If I'm type O, that means I do not have either A or B antigens. And since I don't have A and I don't have B, that means I'm going to make both anti-A and anti-B antibodies. This is the basic rule. There's only two antigens. Whatever antigen I do not have, my body makes an antibody to fight it. And the antibody is called anti whatever the name is, the one that I don't have. All right, hopefully that makes sense. I get it. I know that when you're studying this, you want to move ahead because this seems so basic, but if you've got to understand this underlying principle, because if you don't, it will trip you up. All right, so moving on. This is kind of an interesting chart. I am not going to test you on this. Well, I'll tell you the one thing that I do want you to know. Type O is the most common blood type. All right. Type O is the most common blood type across the board. Now, it is interesting in the different ethnic groups, the changes in the percentages. I am, again, not going to, I'm not going to test you on any of these. Except that I might ask what's the most common type of blood in the ABO system, and it is type O. Now this is a picture, we saw this a little bit in lab, this is a picture just kind of showing the combination. So I have A antigens on my cell surface. That means I do not have B. So B is not my friend, so that means I make anti-B antibodies. This person has antigen A. There is no, or B, there is no antigen A. I was thinking way ahead. There's no antigen A, so I make anti-A antibodies. This person has both A and B antigens, so therefore I will not have any antibodies, none out here. This person doesn't have either one of the antigens. So you're type O, so it's going to have both anti-A antibodies and anti-B antibodies. Now, it's as simple as mixing and matching. I cannot put anything that has an antigen, for instance, A, in a body that has antibody called anti-A. I cannot put antigen B anywhere that has anti-B antibodies. If that happens, they will attack and it will cause what we refer to as agglutination. So that's the basics of it. It doesn't matter anything about the blood types or whatever. Just remember, it's as simple as I cannot put an antigen into a system that has an antibody that will attack it, no matter how it's done. All right. This is a picture kind of talking about agglutination. This is kind of showing as the red blood cells start sticking together. Again, the way I remember it, and it's kind of weird, I have other ways to remember it, but to me, when I was watching the movie The Incredibles a long time ago when it came out, Mr. Incredible's running and all these little sticky balls get shot at him and he can't run anymore and the bad guy catches him. That's what agglutination is. As these cells start sticking together, they can no longer move freely and they clump together. And while it's helping save you, it can be very deadly if it's a lot of blood. All right. So again, that's what it's called, agglutination, or to clump together means to agglutinate. Now, this goes over how this goes over a basic chart of blood typing. If I have type of blood of recipient, preferred blood, type from the donor, what can be used if not there. Here's the thing, just remember, so if I'm type A, that means I have A antigens. I cannot go anywhere that has anti-A antibodies, right? So what would have anti-A antibodies? Any person that doesn't have A antigens. Type B does not have A antigens, so they have anti-A antibodies. I cannot give type A to B. I cannot give A to O because O, since it doesn't have A, I'm not worried about B at all. All I know is it doesn't have A antigens, so that means it has anti-A antibodies. So type A can only give blood to A and AB. If I'm type B, I know I have B antigens. Therefore, I cannot give my blood to anybody that has anti-B antibodies. The people that have anti-B antibodies are people that do not have B on their red blood cell. A doesn't have B, and O doesn't have B. Therefore, both of those have anti-B antibodies, and I cannot give my blood, I cannot donate my blood to them. If I'm type AB, I know I have A and B antigens. I cannot give my blood to anyone that has either anti-A or anti-B antibodies, which means I can only give blood to myself. If I'm type O, that means that I don't have either one of the antibodies or antigens. Therefore, there's no antibody that would trigger it. So if I'm type O, I can give my blood or donate my blood to anyone. That is why O is considered the universal donor, because O, the blood type, has nothing on it that would set off agglutination. Now, let's look at it the other way. If I'm receiving blood, right now, all I'm worried about is whatever antigen that's on the blood coming in, I can't have an antibody that would attack it. So if I'm type A, that means I don't have B antigens. That means I have anti-B antibodies flowing through my system. Therefore, I cannot receive blood from anybody with a B antigen. There are two people that have B antigens. I cannot receive blood from B and AB. If I am type B, that means I don't have A antigens. That means I have anti-A antibodies flowing through my system. So anti-A tells me that I can't have A, anti-A. And so I can't receive blood from type A because obviously they have A antigens. And I can't receive blood from AB because they have A antigens. Now, if I work through that, now I go down to AB. Since I am AB, that means I'm not missing either one of the antigens, so I do not have any antibodies. So therefore, there is no antigen that I could receive that would send a trigger. So that means that type AB is called the universal recipient, because type AB does not have either an anti-A or an anti-B antibody. Therefore, anything can go in it. If I look at the last one, type O, O has neither one of the antigens, so it has both antibodies. Type O can only receive blood from other O's. And so that's the way it works. And so hopefully you get that. Again, this is just a recap of the lab stuff. I went into it probably a little bit more in depth in lab. So let's continue on. Now we look at the RH group. This is a big thing that it throws people off because of one change. Right? First of all, there's only two types, positive or negative. If I have RH, and I'll draw it like this, that means I'm positive. If I do not have it, I'm simply negative. Now, this from birth, neither one of these people, whether I'm positive or negative, have antibodies for this. Both of these types of blood are antibody poor for this reaction. So it takes one cross-contamination. Now, if we were in the RBO system, as soon as there are cross-contamination, boom, agglutination would happen. At this point, what's going to happen is that we have a process of analyzing, recognizing that there's something different, then making the antibody and getting it in production. And by the time the antibody is in production, the cell will be gone. So the first time we come in contact with that blood, there's no visible reaction. There's all kinds of processes going on, but no visible reaction. It takes a second cross-contamination, a second encounter that causes agglutination. And another thing to look at, and up here we're at the cells again. If I am a type positive person and I receive negative blood, there is no chance that there's a problem, right, on the RH factor, because Type negative, the negative blood type doesn't have anything on its surface. So if that happens, there's no trigger. There's nothing my body's going to see as abnormal. However, if I am a negative type and I come in contact with positive blood, that's when it happens. Because if I am negative and I see this in my body, I recognize that it is something not right. And so I'm going to make antibodies to attack it. All right. So the Rh blood group was named for the rhesus monkey. I doubt I'm going to ask anything about that. That's kind of a big part of trivia anyway, but it's all right. The group includes several Rh factor antigens and factors, but most important is the antigen D. This is generally what we just consider the Rh factor. Rh positive means the antigen D is present. If it's Rh negative, they do not have it. Anti-Rh antibodies form only in Rh negative individuals in response to the presence of an Rh antigen. Again, the thing we were talking about right here. Even, right at birth, even if I am an Rh negative person, which is the only one that can have the antibodies in it, because again, if the part positive had the antibodies in it, it would attack itself. So only the Rh negative people can, but it takes a cross contamination to happen to do it. Now the big thing is when it happens to a pregnant mother and what will happen to the fetus. We call it erythroblastosis fetalis, or hemolytic disease of the newborn. This is where the blood attacks the little baby. So this is the way it works. It actually, you have to have two times, basically. If this is how it happens, it's the second childbirth that's the problem. In an Rh negative woman, if she becomes pregnant with an Rh positive child, there starts off a barrier. And so the mother won't notice this right now, and the mother does not have any antibodies in her system that would attack the baby. Because the baby is protected by this little amniotic fluid that the mother doesn't recognize it, and again the mother does not have these little antibodies as of yet. But once the childbirth happens, there's going to be a mixing of the blood, and at that point the mother will make antibodies for it. Now she has antibodies. So if she gets pregnant a second time with an Rh positive baby, her antibodies will cross the placenta and attack the baby and kill it. And so right now we can, and especially most developed countries, we can avoid this by a drug called Rogan, which stops this process. And so if you are pregnant, you usually are administered Rogan. Now, this is a little list of the diseases and inherited blood disorders. I am not going to, I'm not going to, this isn't going to be a big part of the test. What I want you to know, sickle cell disease is basically an abnormal hemoglobin. We talked about that a little bit. It causes anemia. Because you should know anemia is a low blood carrying condition, a condition of low blood oxygen. And so if the sickle cell disease has an abnormal hemoglobin, it makes it to where it can't carry oxygen efficiently. These others, I'm not really, they're good to know where they are, but we're not going to get into these. We're not going to get into these in the test.